Right. Hello, guys. So I thought I would sort of switch to a weekly update format because I realized that when I was coding live, I basically just spend a lot of time talking to myself or murmuring under my breath, like, oh, so we're gonna do this and then we're gonna do that. And I'm mostly just talking to myself. I don't know how interesting that is, so um, thought it might be more interesting instead, at least to begin with, to switch over to a weekly update format and just talk about what I've been working on in the last week. So I still want it to be a little bit off the cuff, not too much, not too scripted, or not scripted at all. I'm just gonna talk about a few things that I worked on this week. I had actually started recording some of this stuff as live coding videos, but didn't really like how they turned out, especially when I get locked in. Just don't really make much sense when I'm talking. I'm not sure how interesting that is, but all right. We just open up my Emacs, and then we can start talking about that. Um, one of these days, I really need to set the default font instead of having to open it. Right now, every time I open Emacs, I change the font manually, and it's not ideal. But I actually use Emacs mostly on the terminal, so the font and font size settings are irrelevant to me. I use it in the terminal in the work context, I should say. I do prefer the graphical interface, but at work I don't really have a choice. But okay, so I have our Emacs here. And the first thing I wanted to talk about is, maybe I just outline. So I did some work on Mill, which is my Lisp, is the Lisp variant that I'm aspirationally working towards. I don't know how much I talked about it. It's just supposed to be a more explicit, higher performance Lisp. In particular, no default garbage collection. Um, so what we did in that respect, let me just switch to work mode. What we did in that respect was the Lexer. We have a very basic Lexer. It took entirely too much time. And in addition to the Lexer, we did some tests, which brings me to the second point, which is some work on the trinkets collection of libraries, specifically a C++, C++ test framework. Very simple, but thought it'd be interesting to at least talk about. Just looking at my notes here. Oh, the other thing I did was a Common Lisp CLI application. I don't know what the right word for that is. And this is for a quotes database, so I can talk a bit about that. It was my first time writing a CLI in Common Lisp and thinking about the packaging of it, which admittedly is not Common Lisp's strong suit. But we can talk about that. And finally, I don't know, just completely in another direction, I was thinking a lot about a specific part of Rachmaninoff's Second Piano Concerto, the first movement. So yeah, so let's start with, make this bigger. Let's start with the Lexer. So I'll go into my mill. This is the project directory, right? So what we did was, yeah, this two, lexer.h and lexer.cpp. Oops. Right. So we guess just talk about lexer.h. So my Lexer is very simple. It takes in a string and just produces a vector of tokens, a list of tokens. And what is a token? Well, a token is, just double check something. Make sure I'm using the right microphone here. Yep, okay. So what is a token? A token is, well, an enum specifying the kind, which we just look up here. You know, you have left parentheses, right parentheses, identifier, 32-bit integer, literal, 64-bit floating point integer, or floating point literal. So yeah, the choice of the literals, at least for now, these are what I'm thinking for the defaults if you don't explicitly specify anything. So if I just write like -32, then that should be parsed as an 32-bit integer. The reasoning is that if you're not, in my opinion, if you're not specifying the type explicitly, the 32-bit integer is usually what you want most of the time. And I guess it's more interesting to talk about the case of the 64-bit floating point integer because, my opinion, if you write a floating point, most of the time you are going to want a 64-bit floating point. And the reasoning behind that is if you're dealing with floating points, you presumably care about, I don't know exactly where I read this, but if you're, so it's not a totally original idea, but if you're writing a floating point, you're dealing with floating points in your code, presumably you care about precision. So we should just default to the highest precision asterisk type that's supported natively. Yeah, so that was the reasoning behind that. So those are the types. Then you have the data. So each of these types could have associated data. Like when we're lexing at that time, we might want to parse or otherwise store data associated with the token. So I think right now, where do I have it? Token data. Oh yeah, right here. So the token data right now is nothing but either a 32-bit integer or a 64-bit float. And yeah, I was initially going to, so obviously you don't need to store any data for the left and right parentheses. I should say right now, as you can see, there's a separate part of the token that's specifically for the source code location. So every token will store that data. But in addition to that, you don't need to store anything for the left or right parentheses. You could say for the identifier you want to store something, namely the name of the identifier, or the text or string. I voted against that, mostly because you can just derive that from the source code location, right? So that's the token. So I was recording this while I was coding it, and one of the reasons I decided to scrap it because I spent entirely too long. Like initially, this was a union, and I had a field for the string view. I was gonna do like a std string view for the identifier. And for the longest time, I was running into like seg faults. Well, first there was a compilation error because apparently you can't have a complex type in a union. And then I was dealing with seg faults because apparently, yeah, the way I was creating the string view was really dumb. I would be like doing like, I was taking the string and then taking like the substring of it. This is all in a function. And then I would be converting that to a string view. And so I was creating the problem was I was creating a temporary string, then creating a view of that string. So when I left the function, it didn't work. What was weird was that I tried printing out the pointers because I knew something like that was happening. It's a seg fault after all. But the pointers uh, didn't really reveal anything. Like this string view was still pointing to what was pointed to by the original string. It was really weird. But I'm pretty sure that's what was going on. But anyways, that led me to the current design, which I think is better anyways. So the Lexer itself is a class. I mean, I'm not a huge fan of classes for everything. The reason I'm using it here mostly was because of the code point state, the state of reading the string. So it was just easier to like store the progress we made in reading the string as class member variables to have them not have to be explicitly passed to each of these functions instead of like having to pass like what the current byte offset is as a pointer and have that updated, pass the string, stuff like that. Yeah, so I already said like we're just Lexing and this is just the implementation of it. So like I said, instead of storing the string view for the identifier, you can just derive it from the source code location. So yeah, these are all the functions. This is kind of using the code point reading library that we had written last time. And now I want to say something. Revert the buffer because I don't want to save any of the changes. Okay, CPP. So the most interesting thing that I want to talk about here is the testing. So it became clear that I would need to test it. I mean, I'm the type of person who writes all their source code, especially with this. I wrote all the source code without even compiling it at first. Then I compile it, deal with the myriad errors, and then I test it. Is that the best approach? Maybe not, but that's how I do it, and totally sufficient for personal projects, I think. So I wanted a framework, or at least a way to test the code. And I was looking at some pre-built solutions. So the first idea was to generate Python bindings, right? And test the code from Python. That's how we test code at my job. My job, our product is written primarily in C++, but we generate Python bindings automatically as part of the, I don't know what you call it, like the build process, I guess. And we just test it from Python. So that has a lot of benefits. You don't have to worry about some of the lower level concerns that you would have to worry about if you write your tests in C++. Another thing that a lot of people don't mention is that it's kind of nice to have that separation between the implementation language and the testing language because it forces you to create a testable API, It has its downsides. You don't want to make everything, make all private functions public, for example, but there's something to be said about being thoughtful about the API you're producing and being thoughtful to create an API that is easily testable, a public API. So I was thinking about that. I think we use an in-house solution at my work. I'm not entirely sure. I mean, I'm sure we use some dependency somewhere, but it's customized. But there's existing libraries to generate Python bindings from your C++ automatically. The most popular of which I think is this PyBind 11. And then there's a newer successor. So PyBind is a pretty featureful thing, and this guy who made that also created afterwards this nanobind library, which is a smaller feature set, more efficient library. So I was really thinking about this. In both cases, though, there's a somewhat involved build process, and really I don't even care about all those features. I just want to write a function, make some assertions, and that's it. And I don't even care if you have a lot of these features. I mean, I actually did read an interesting, I think it was a Reddit comment that said that PyBind 11 played a big role in the mainstreamification of Python. So if I remember correctly, and again, this was just based on a Reddit comment, Python 3.6 was going to be released. So apparently that's the release where Python really went mainstream. It was that's where it got huge adoption. And Python 3.6 at the time before it was released had a regression in its dictionary mechanism, which the developers knew about, but they thought the performance hit wasn't that severe. PyBind 11 came around, started testing, I guess, the pre-release version of Python 3.6, and because of their extensive testing framework to test PyBind itself, they uncovered just how detrimental this bug in the Python dictionary was, how slow it was. And really that's what's convinced the developers to invest the time to fix the bug before the release. Apparently that played a big role. So I thought that was an interesting bit of history. Yeah, so ultimately, like this is a whole nother build step, right? And then you had to maintain these bindings. I don't know if things will break. It just seemed overkill, you know. So what the alternative is to write your tests in the language itself, C++ in this case. There do exist a lot of tools to do this. I think the most famous is Google Test. It's their own C++ framework. A lot of people don't like it for smaller projects though because it's pretty complicated. There's a lot of confusing macros. I think I used it once a year ago for a small project. It was fine. Yeah. The a more popular one, at least for the medium to small range project size, is Catch 2. So they have a good example here. The way you would write a test, you can just write it next to your product code, and you declare the test with this test case. You make your assertions using these macros. So, and obviously they have a lot of features too. Like you can have shared code to like set up and tear down the test. It's good. I thought if this is all we're doing, like maybe I could write it myself. And that's pretty much what I did. But I did, leave out the most complicated parts. So this test case macro here, like what is it really doing? If we, I was thinking maybe we could look at it, but I'll just explain it verbally. What this is doing is it's a macro that declares a function. So it's generating the function name such that it's unique. It's declaring that function. It's doing some extra stuff with setup and teardown. And then it's also registering that function. So what do I mean by registering? It's basically creating the macro itself is saying this is a test function, and it's basically storing it in a set, like a global variable set or hash map or something. And when you compile the test using their mechanism, what they'll do is basically they'll have a main function, and then their main function will just iterate through that global set variable and just call all the functions that are in there. And that way, they're guaranteeing that you're just calling all the tests. I'm sure you can sort of specify which tests or test suites you want to do, but that's the basic idea. That is a little bit more complex, and if you do those features, I'm pretty sure you have to commit to C++. You can't have the same framework for C. There's actually a pretty good test on, a pretty good video on how stuff like this works that I was watching that helped me in this evaluation. Let me try to find it. Doc test C++ talk, something like that. Yep, this CPPCon video by the guy who wrote it, Viktor Kirillov. It's pretty good. I would recommend checking it out if you're interested in that stuff. But again, this is another dependency, and I thought I could do with a lot less in a lot less, if that makes sense. So that's when I went to my handy little trinkets library, which, if you remember, is my shared utilities across languages. And I went into here and I created a test library. And it's really short, 30 lines of code. I don't know what the phrase is, 30 lines. I think lines of code doesn't account for white space or something like that. But 33, the file is like 33 lines. What does it do? So, okay, you have a test context that you pass around. Doesn't do anything special right now, just keeps track of the number of failures. Then you have a begin test, end test, and test assert. And what does this do? So actually, I think it would be cool if we look at something else that I was doing, because I was working on this library, and this is a common utilities. Be nice to have some nice documentation. So I looked into ways I could document it, and I found this thing called Texinfo, which is obviously well known, I'm sure, but it's a documentation system based on Tech, initially or primarily used by the GNU system, and actually natively accessible in Emacs. That was a pretty big motivating factor. This is like a personal library. I use Emacs. So this is it. It's just MX info. And yeah, like you can view the Emacs manual in here. So if I Emacs, I guess this might not be super updated. But like, yeah, you can view like the Magit manual. Up. So they have some key bindings that I'm still getting used to. Yeah, and this is a pretty nice way to view documentation. So you can write your own, and that's what I did. Go up. That's what this Texinfo files are, and it generates this info file. So that file is generated by, I don't think I actually wrote how to generate it. I think the command is like make info or something. Yeah, make info. Let's just see what it is. Make info. Maybe make info doc.texinfo. Does that work? Yep, see, so this file just updated. That was pretty simple. And then you can view that file by doing, I should probably check what key this is, but I'm just doing prefix Control-HI. And now I point to the file, so doc.info. And there we go. So if we go to the test, then C++, you can just see the documentation here. So the philosophy is simple. Number one, no execution framework. So I'm not saying anything about how you compile this into an executable and run it. That's sort of on the user, aka me. Also, no automatic test function registration, so we don't have that like test macro that declares a function and registers it. And those two are related, right? Like we can't automatically generate a test executable if we don't know what are the test functions. So, and those two really helped minimize the scope. I mean, this is how you would write a test now. You just declare a function that just takes a context parameter. Doesn't matter how you name it. Doesn't matter where you define it, really. And then at the beginning, you just say begin test. I think the intention is for this to be sort of opaque, but I can just say right now all it does is print out the test name and description. So then you do your testing logic, which is something, a lot of asserts. Now I will say like the Catch 2 framework, other frameworks are a lot better about this. So mine will just say assertion failed. They will actually like expand the like left hand side and right hand side and say like why it failed or like show the values and show how they differ. I'd like to know how to do that, but I don't really know. It didn't seem immediately obvious to me how to do that. And I don't know if you could maintain like C compatibility in that case. Though presumably it's some like compiler extension. And then at the end you do end test. And so how did I do this? Basically when the assertion fails, so what this end test is doing, and maybe this would be a better time to go to the test.h file. What this end test is doing is just defining a bunch of labels. And when we assert, if we fail, then we will we jump to the failure label, right? And okay, we pass all the asserts, then we will just fall through, we'll just continue on, we'll hit the generated pass label, which right now just prints out that it passed. And then in both cases, pass or fail, we'll just jump straight to the teardown, which is the last label. And what that allows you to do is right after this end test, right below it, you can include any teardown logic that will run regardless of if the test passed or failed. So like closing a database connection, doing whatever, blah, blah, blah. And I thought I think that's pretty good. I mean, that's all I would want to do. And so I give some ideas on how to actually integrate this. And to that end, it might actually be useful to see how I integrated it. So first of all, I'm only including that header and headers that are only used in tests. I'm making that conditional on this macro, or this, I don't know what you call it, constant, definition, whatever, mil test. And then for the actual test functions, if we look at them, they're only compiled in that case. And it's like I said, we just, begin test. I did find that I needed to put these in like braces, or else you had like some compilation warning or error about the go-tos. But yeah, so do I have any other test functions that are interesting? Yeah, I don't think I actually used the teardown logic yet, but it's there. Like, yeah, I mean, it's pretty verbose, but it's okay. I mean, it's 30 lines of code and you get a testing framework. I guess maybe you might not call it testing framework, but that's all right. And then what do I do to actually run the test? So if it's defined to be the test, we're compiling as the test, you include the test header, extern define all the test functions. So yeah, I mean, you don't really want to put those in a header because they're not really part of the API, right? So just extern define them. This does put a lot more on the user, right? Like the user has to know not to produce duplicate names. They have to like explicitly register it like this and explicitly call it like. So in the case I'm compiling as a test, I define a separate main function, which just inits some stuff and calls all the test functions. Otherwise, so if we're not in the test mode, then you'd call the actual main function. You compile the actual main function and call it. Yeah. So that's the testing framework. And I should say, like, also the the tech info thing. There unfortunately isn't a way to generate Markdown. I did try like going through Pandoc, generating first an HTML and then a Markdown for the sake of the GitHub README. It didn't work out that well. So they do support generating just plain text, and that's what the README is. Yeah, so it's just the same thing, but as a single plain text file. And actually, I have it set up so I can show you if I go to trinkets. If I go to .git hooks pre-commit, yeah. So I have this pre-commit hook that just will generate that README and add it. And then it will be part of the commit. All right. So I think that's what I wanted to say for the C++ and the testing framework and Lexing. The other thing, so the next step, maybe I should say first, is to write the parser. That's probably what I'm going to work on next week. Hopefully that's more straightforward. Right now I'm just trying to lex and parse a pretty simple subset because I think that the most difficult part will be integrating it with the LLVM org APIs, also known as the JIT APIs, because I want to have native performance. So maybe in the future we, for fun, just have a backend that's a. I don't really care for tree walking interpreters. I could see we have a backend that's based on a virtual machine that we write. Probably register based. Okay. So where are we? Let's look at my Scratch. What did I want to say? So we did this. We did that. Now we are on this Common Lisp CLI application. So let me just go into this project. My idea was, I don't really have this as a concrete idea, but I've been thinking about writing my own sort of desktop environment, very similar to Emacs. And I was like, it would be pretty cool, a little weird, but pretty cool, pretty whimsical, if I just had like quotes, scrolling across the mini buffer or wherever on the screen, quotes that I came up with. And that, like, I don't know, like, I just randomly see a quote from a couple years ago. That'd be kind of interesting. I was also thinking that desktop environment could have like a soundtrack, kind of like Minecraft. And maybe the quotes could be matching in mood with the music. It seemed like a small, fun idea that you could just do in like an evening or two. That's what I did. So let me just show you sort of what that is. So I think it's quotes Lisp. So it's a nice CLI application, and I can list quotes, and you can also insert quotes. So, but these are the quotes that I have in it right now. And thinking to that application to my desktop environment, you can also get like a random quote. And like say you want a random quote for a neutral mood. Yeah. So that's basically it. And the quotes are stored in a SQLite database. Maybe overkill, but that's how it is. And so I just put these like quotes in. Why do we write software we won't use for people who will never use it? This has been a big perspective shift. I think that's really allowed me to take the next step. It sounds so corny, but once I started writing the software I wanted to write and like not caring if anyone is going to use it other than me, once I started writing software for me, I started writing more software, and like my creativity just started with respect to software just started flowing. And it's kind of this quotes database is kind of an example of that, I guess. You know, it's such a dumb idea, but I use it. I think software can be really dreadful and boring and tedious when you're purely writing it for you're purely writing programs you'll never use, you know. All right. Ah, the washer is done. We'll keep beeping. All right, the second quote was, I wish I still had sleepovers. Hey, I mean, I had some great times at sleepovers as a kid. Can you hear the trumpets? I don't know. Can you? I'm going to use isomorphism colloquially to mean equal but not literally. And no, I will not be expanding further. So yeah, I mean, it's kind of an interesting. I don't know. Definitely, people other than math people use it, especially computer people. You just say like, you know, this the way of writing it like this is isomorphic to that. I don't know. And what you mean by that is like, are they literally the same? No. Like, are two approaches doing the same thing? Literally doing the same thing? No, but they're isomorphic, you know, like they're like pretty much doing the same thing. And it's not even like super clear to me like what that means concretely, and it's definitely not consistent in all the uses. Because I mean, this is dumb, but I'm just thinking about it. Like, is anything like truly equal? I don't know. I mean, you have to set the baseline somewhere, right? You have to set the baseline and say like, this is what I mean when I say literally equal. And then it makes sense to talk about an isomorphism, but it's just implicit. I don't know. I mean, is that irresponsible? Maybe. So those are the quotes. And before I continue, let me turn off the washer so it doesn't beep. All right. So I thought it would be fun. I mean, this is a small project. I thought it'd be fun to just write it in Common Lisp. I actually do quite like Common Lisp, and if I had more control over the low level stuff, I mean, maybe I wouldn't be writing my own Lisp. And I got really pissed off, if I'm being honest, when I just for the life of me couldn't get um, graphical stuff to work, like opening a window. Just couldn't get that to work because of the SBCL like threading stuff. And maybe now that I think about it, maybe it would have worked if I wasn't running it from Emacs, but you know, it is what it is. All right. So I just created like a system quotes. It just depends on two things: the CL SQLite library and the Klingon library for CLI parsing, which is how I get all this nice formatting and support for CLI stuff. And if I just like, maybe I'll just briefly talk about it. The SQL stuff isn't too interesting in my opinion. It was interesting, but maybe not super interesting to talk about. Because I guess you could say the interest comes from how it's implemented. It's just a simple database with like an ID, date added, quote, and moved field. You just have some functions to print it. Oh, so I'm representing it as a class. Creating it if it doesn't exist, retrieving it, blah blah blah. An interesting thing that I wanted to talk about is like this way that they're doing the CLI. So the way Klingon works is you define a CLI command, and the command takes options, which we'll get to, and it takes a handler, which is this function, which also doesn't do anything because the top level command doesn't actually do anything. Now you can also list subcommands. So if you like have a subcommand, then it has its own set of options and stuff. And so I don't know if other frameworks do it like this. Sure they do, but it's pretty clever to represent that as also a command and just say, oh, it's a subcommand of the top level command. It makes it very easily composable, I guess. And so we have the insert. If you look on the right here, insert, list, and random. And I'll just talk about like the list one. So you can list options, and these are these like double dash flags that I use like here with the dash dash mood. Yeah, so you just say what type it is it required, long name, description, and this key is how you end up accessing it. That's relevant in the handler when you can retrieve the values like by using that key. And then you just do whatever you want with it, which for me is just print out based on those inputs. So there's that. Pretty neat and pretty enjoyable to develop in. I actually did write some tests, and I was thinking about doing another testing framework, but didn't seem so straightforward. Still like what I was looking for, especially because the execution model is a little different in Common Lisp. And you can just execute these things like in the REPL itself, So I just defined a function and just had some assertions in it. And that's all. Also, I learned, and I don't know how I missed this before, that you can just, especially for testing purposes, it's pretty useful to just have an in-memory SQLite database that just goes away when you disconnect from it. Pretty good for testing, so you don't have to deal with the actual on-disk database. So then there was the question of how are we actually going to run it, right? And I think if you, I'd probably talk about it in the read. That's the wrong read. Yeah. So, I'll open this on my GitHub. Oh, quotes. Right. So you could run it as a script, which is what I did initially, because that was just easier. You just add some lines to like this line, load sbclrc. That just makes sure you load some of those default packages like QuickLisp and ASDF, stuff like that you would need to use your dependencies like Klingon and SQLite. And then of course at the very bottom, so it's evaluated top to bottom, then just like call main explicitly. It'll probably do what you want. Yeah, and if since now we're in a system, packaged it as a system, you're not in the CL user package. So if you're in the REPL, you need to push the path to it and then load the ASDF system. But most of the time you have a CLI application, you're thinking of it as an executable. You're packaging it as an executable, particularly because, right, if you launch it as a script, you have to think like it's starting up. It's like evaluating everything at the time you're running it, which it's not that bad, to be honest. It's a little bit better to make it an executable, which is its whole thing. It's a whole thing in Common Lisp, right? Really the way to do it, the standard way to do it, I guess I don't mean standard, like literally as in the ANSI standard, but the standard way to do it is to just dump the image, like your live Lisp image that you're working on in the REPL or whatever. You just dump that to the file and make it executable, which is what I am doing. And the way I do it, I just created a simple make file that will do it for me. What does it do? It just invokes SBCL and it evaluates a couple of forms. Then it just dumps it to the image. So what is it doing? So it's doing like what I said to do in the REPL. So it's adding that current directory. Then it's loading it. Then it's calling this ASDF make, which I guess is what's dumping the image. And then, so I based this off of something from Stack Overflow. But so I guess this is dumping the image. And then it's quitting. I think this is also what Klingon, the documentation for Klingon suggests as well. And so it's pretty fast. It's definitely serviceably fast. Let me remove quotes and then just make it again. So yeah, it says, I don't know if there's an Emacs update, but I like how it says the time now. It says 0.7 seconds. That's pretty good. Pretty good. If you look at the actual thing that it generated though, like, oh my god, it is 44 megabytes for a super simple application. I mean, maybe it's packaging the dependencies, but even then 44 megabytes is kind of crazy. You have to remember though, what it's doing is dumping the image. And since the compiler is accessible at runtime, when you dump the image, you're dumping the compiler. So what you have here is an executable that not only includes your code, but also an entire Common Lisp compiler. And the result is a 44 megabyte behemoth. So there you go. That's how you do it. I'm also version controlling the database because honestly, that's more important. You could write. I wrote it in I wrote the interface to it in Common Lisp just because it was interesting. It was fun to write. But you give it to me and tell me to write it in Python, I'll probably do it in like an hour or two. You know, like this is not a very complicated program. The database is really what's important. All right, so I think that's what I wanted to talk about there. And that brings us to the last one, just a short thing. Rock 2. I was listening to the Rachmaninoff Piano Concerto number 2, and I won't play it out loud, but this has been one of my favorite pieces. It's meant a lot to me since I first heard it. Must have been almost 8 years ago, I want to say. And I've liked a lot of different performances. I think the one that I liked for the early on, so the person who got me into it, I think a lot of people interested in this space will agree that the gateway to it is Anna, I forgot her name unfortunately. Anna Rock 2. Yep, this Anna Fedorova. This performance, and still holds up. I mean, it's a wonderful performance. It's a live performance. It says a lot. Then I liked this Rubinstein Rock 2. And the part I really liked for this is, if I can remember correctly, it's called like the Infernal March. It's the part in the piece, in the first movement. The first movement is my favorite. I like all the movements, but first movement's my favorite. It's the part where it goes dun 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 dun. Has a lot of energy. And I think Rubinstein, the way he plays it, he sort of just like commands the orchestra in that part. Like he's really just like pulling them, he's commanding them in that part. In a way that the other performers don't do as much. At least that's what I thought at the time. And then, as of late, I'd say the last couple years, this has been the definitive performance of, for me, I like parts of both, so I wouldn't say it's like the definitive maybe, but I've really grown to appreciate this. And something about Zimmerman, in my opinion, is that he plays things very I don't know how to describe it. Like he just plays it very, very perfectly. That makes sense. Like he's not too expressive. He's expressive, but also like has a lot of restraint. It's just played like very crisply, perfectly. And this is the king of piano. I mean, I expect nothing less. There's a certain maturity in the way he plays. And I think so. This week I was listening to the very ending in particular. Um, so I don't think you can hear this. So I don't think this will be an issue. So right around here, the way he plays this part is just so much more poignant than I've heard any other performer. He just plays it like with such tenderness that, yeah, just like a lot of tenderness. Very, I don't know. I don't know. It's his interpretation of this part is just for me miles ahead of anything I've ever heard. And it's truly like one of the most beautiful passages in the piano repertoire, I guess. So I would recommend you listen to this part, and especially like compared to how other people play the part. Even though I think this is the definitive part, it's enjoyable to me to hear how other people interpret it. And do keep in mind that there is a difference between pre-recorded performances and live performances. So, yeah, I think that was all I wanted to cover today. Next week, I will be working on the parser. Maybe be adding some more quotes to the database. We'll see. Maybe that'll be a weekly thing. Just look at the quotes that have been added to the database. I also had an idea for like a specific visual effect that I might put into the desktop environment. Maybe I'll play around with that in Raylib just to sort of flesh out that idea a bit. Yeah. All right. See you guys next week.